Today we are going to start with class 12 syllabus. The first chapter, solid state. Now in class 12, we have two books. Book 1 consists of 9 chapters in which we will have physical chemistry and plus we will have inorganic chemistry. Whereas book 2 comprises of only organic chemistry. In this entire syllabus of your plus 2, there are only 4 chapters from which numericals they can come in your boards. Like the first chapter solid state, the second is solutions, the third is electrochemistry and the fourth is kinetics. Rest of the chapters we will have conceptual questions, we will have certain reactions, and in organic chemistry we have name reactions and mechanisms. So let's start with the first chapter today, that is solid states. When we are talking of solids, it is one of the states of matter. You have already studied this in class 11. That states of matter, the physical classification of matter, we classify solids, we classify substances into solids, or we classify matter into solids, liquids and gases. Gases and liquids you have done in class 11. So we are going to do solid state in class 12. We all know, we have studied since our junior classes, that in solids the constituent particles are very closely packed. As a result of which they have a definite shape and volume, and which gives solids their specific property which is known as rigidity. Meaning that when we are trying to apply pressure on a solid, the solid does not change its shape. So that is what rigid is. It is not easy to change the shape of solids. When we are talking of solids, solids is of very great interest to the scientists. Why? Because whenever the scientists they are studying solids, by intermixing the solids, they can make alloys. By putting some impurities on the solids, they can convert insulators into conductors, and also by changing the temperature of the solids, the magnetic properties of the solids can also be changed. So all this we are going to study in this chapter. Today we go on to only the introduction of solids, its types and its classification. Okay, so let's start. When we are talking of solids, the general characteristics of solids would be what? You know that the first one, general characteristics of solids. The first we have already mentioned, that the solids they are rigid, which means they have definite shape and volume. Number 2, their constituent particles are very closely packed. Their constituent particles are very closely packed, as a result of which they have very little distance between the constant particles, but the forces of attraction are very, very strong. As a result of this, the solids they are almost incompressible. By incompressibility, what do we mean? That when we are applying pressure on a solid, we are unable to change its volume. So that is what incompressibility is. Then next, density of solids. Density of solids is greater than liquids or gases. Okay, so density of solids, that is greater than liquids or gases, and solids, they diffuse very slowly. In fact, when we are talking of solids, what we say that they do not diffuse at all. So they do not have the property of diffusion. What do we understand by diffusion? Diffusion means intermixing with one another. So they do not have the property of diffusion. Obviously, if there is no intermolecular space between the solids, diffusion cannot take place. And they have generally, or you can say they can change from solid to liquid state by heating. Okay, so when we are heating the solids they get converted into the liquid state. This process is known as melting, and the temperature at which the solid gets converted into liquid, that is known as melting point. Okay, so these are the general characteristics of solids. Then next topic is classification of solids. Classification of solids. The solids, they are generally classified on the basis of arrangement of their constituent particles. So when we are classifying the solids can be classified into crystalline and amorphous. Crystalline and amorphous. Now, what are crystalline solids? In crystalline solids, the constituent particles are orderly arranged. They are orderly arranged, or in other words, we can say that they have a set pattern of arrangement. Okay, so for example, if we are taking any solid, we will do in the next section when we are doing the crystalline solids, that the constituent particles would be present at a specific portion of the entire crystal. So that is known as orderly arrangement, right? Because of orderly arrangement, it is seen that the same molecules, or you can see the pattern keeps on repeating after intervals of time. So this repetition of the same particles or the same arrangement for a longer structure, this is known as what? It is known as long range order. So if you want to define what long range order is, you can write down that when the constituent particles have a regular arrangement, over a larger area of the substance, that is known as long range order. Okay, whereas when we are talking of amorphous substances, the constituent particles are randomly arranged. Constituent particles are randomly arranged, मतलब कि कुछ देर के बाद जो पैटर्न होता है मॉलिक्यूल्स का वो चेंज होता रहता है, या constituent particles का वो चेंज होता रहता है, right? So as a result of this we say that the amorphous substances, they have short range order. So what did we say? That the crystalline substances, they have an orderly arrangement in which the same molecules, they keep repeating their pattern after specific intervals of time, और इसको हम क्या बुला रहे हैं? इसे हम बुला रहे हैं long range order. Similarly, amorphous substances में जो constituent particles होते हैं वो randomly arranged हैं, as a result of which उनका जो pattern है वो कुछ intervals के बाद change होता रहता है, इसलिए हम उसको क्या बुलाते हैं? That the amorphous, they have short range order. The second point of difference, in fact the third point of difference जो कि हम यहाँ पे लिख सकते हैं, that is the crystalline solids, they are anisotropic in nature. What do we understand by the term anisotropic? It means having different properties in different directions. They have different properties in different directions. What does this mean? That whenever we are doing a crystalline substance, let's just illustrate it. So we are saying that this is a crystalline solid in which the same pattern is repeating, so therefore it has a long range order. Now we are going to see two different directions. One direction, let's say, is this, when we are going from A to A dash, okay, and the second direction is this, when we are moving from B to B dash. Now let's move from A to A dash. When we are going from A to A dash, you can see over here that there are different molecules or there are different constituent particles, as a result of which the property which we are measuring in this direction is going to be different than the property which we are measuring in this direction. That is, when we are traveling from B to B dash, तो एक ही जैसे particles नजर आ रहे हैं, और अगर हम A से A dash में जा रहे हैं तो हमें different particles नजर आ रहे हैं. तो अगर हम कोई भी property इन दोनों directions में measure करना चाहें तो properties different होगी. कौन सी properties different हो सकती है? जैसे thermal conductivity. Thermal conductivity will be different जब हम यहाँ पे measure कर रहे हैं और जब हम यहाँ पे measure कर रहे हैं. और refractive index, अगर हम इस डायरेक्शन में मेजर कर रहे हैं तो रिफ्रैक्टिव इंडेक्स की वैल्यू अलग आएगी, और अगर हम यहाँ पे मेजर कर रहे हैं तो रिफ्रैक्टिव इंडेक्स की वैल्यू अलग आएगी. सो सच सब्सटेंसेस जिनकी डिफरेंट प्रॉपर्टीज होती है डिफरेंट डायरेक्शंस में, उनको हम क्या बुलाते हैं? दे आर नोन एज एनाइसोट्रोपिक. देन द सेकंड, द डिफरेंस ओवर हियर, the amorphous solids, they are isotropic in nature. Isotropic का मतलब क्या हुआ? They have same properties in all directions. Okay, so they have same properties in all directions. Why ऐसा क्यों हो रहा है कि they are having same properties in all directions? That is because isotropic में या amorphous solids में जो particles होते हैं वो randomly arranged होते हैं. क्योंकि वो randomly arranged होते हैं तो उसका कोई भी specific pattern नहीं है, तो आप किसी भी side को measure करेंगे तो properties जो उसकी होगी it is going to be same. Okay, so these are 3 points of differences we have done. The fourth point of difference we have is cleavage. The crystalline solids have a clean cleavage. understand by a clean cleavage? Clean cleavage means कि अगर हम एक crystalline substance को cut करना चाह रहे हैं with the help of a knife, तो it will have a absolutely uniform cleavage. जब हम उसे काटेंगे तो वो एक ही तरह से कटेगा, ठीक है? It will have a sharp cleavage. Whereas जब हम लोग इसकी बात करते हैं amorphous की, क्योंकि particles haphazardly arranged हैं, therefore जब हम इसे कट करें तो then they do not have a sharp cleavage or they do not have a clean cleavage. Then another very important difference between these are, in case of crystalline solids we say that they have a sharp melting point. They have a sharp melting point. By sharp melting point, what do we understand? कि अगर suppose हम ice ले रहे हैं, तो ice का melting point is taken to be at 0 degree Celsius. तो 0 degree Celsius पे ice जो है वो melt हो जाती है, okay? ऐसा नहीं होता कि भी ice melt शुरू हुई है होना 0 degree पे और वो 5 degrees पे तक melt की होती चली जा रही है. That does not happen. So crystalline जो है, they just melt at one particular temperature. They do not keep melting over a range of temperature. इसलिए हम बोलते हैं कि इनका sharp melting point है. Whereas जो amorphous हैं, they do not have a sharp melting point. They do not have a sharp melting point, which means that they keep melting over a range of temperature. जैसे charcoal हम लेते हैं, charcoal is an example of amorphous substance. तो charcoal को जब हम burn करते हैं तो आपने देखा है कि वो एकदम से melt नहीं होता, तो उसका हम melting point properly record भी नहीं कर पाते because it keeps melting over a range of temperature. So these are the differences between crystalline and amorphous. अब इसमें कुछ आप कह सकते हो कुछ exemptions हैं या आप कह सकते हो कि इसमें कुछ थोड़े से different substances हैं जो दिखते हमें solids की तरह हैं but वो behave करते हैं, या जो दिखते हमें crystalline की तरह हैं पर वो behave करते हैं amorphous की तरह. Okay, there are certain substances like that also. And secondly, कुछ substances ऐसे होते हैं कि जो दिखते solids हैं but they are liquids. Such substances जो कि हमें दिखते solids हैं but basically they are not solids, they are known as pseudo-solids. Pseudo-solids means false solids. Okay, so they are known as pseudo-solids. For example, glass. For example, glass. Glass basically is a supercooled liquid. Supercooled liquid. कैसे पता चलता है हमें कि ग्लास एक supercooled liquid है? जब हम कोई भी पुरानी बिल्डिंग्स देखते हैं जो काफी साल पहले बनी हुई हैं, तो उनका जो विंडो पेन्स होते हैं उनके जो ग्लासेस होते हैं वो नीचे से थिक होते हैं और ऊपर से थिन होते हैं. That is because due to exposure to the heat of the sun, धीरे धीरे जो अपर पार्ट है वो मेल्ट होता चला गया, as a result of which वो नीचे की तरफ को थिक हो जाता है और ऊपर की तरफ को थिन रह जाता है. So that tells us that glass is a supercooled liquid. Okay. Now, इसके साथ साथ there are two terms which you should know. The difference between isomorphism and polymorphism. So what do we understand by two terms? One is isomorphism. Isomorphism. What do we understand by this term? It means that existence of two or more crystalline solids having similar chemical composition in same crystalline form. In same crystalline form. Existence of two or more crystalline solids having similar composition in the same crystalline form. For example, if we are looking at sodium phosphate and we are looking at sodium arsenate. Sodium phosphate and sodium arsenate, they both are crystalline solids having similar chemical composition in same crystalline form. Similar chemical composition in same crystalline form. So therefore they are isomorphs of each other. The second term I told you was polymorphism. Polymorphism क्या होता है? Existence of a particular substance in more than one crystalline form. For example, calcium carbonate. Calcium carbonate exists in two different crystalline forms. One is calcite and the other one is argonite. Right? So what is the difference over here? You can see that over here two different chemical substances are sharing the same structure and the same chemical composition, whereas polymorphism में एक particular compound जो है या एक particular crystal जो है उसके दो different crystalline forms हैं. जब हम elements देखते हैं तो in case of elements polymorphism को हम एक और नाम देते हैं which is known as allotropic forms. Like you know that carbon has two allotropes. One is graphite and the other one is diamond. Okay, so you understood the difference between isomorphism and polymorphism. By chance अगर कोई question आ जाता है कि which of the following pairs are isomorphous with each other? So the hint is that in isomorphism, the chemical combination of elements that is same, right? The chemical combination of elements is same and they also share the same structure, right? Whereas polymorphism में एक ही crystal जो है उसके दो different crystalline forms हैं. Clear हो गया? Okay. Then one more question which comes is that why the glasses of old buildings appear milky to us? This is another question. Okay, so your question is why the glasses of old buildings appear milky in nature. The answer to this is that when we are heating a solid and then slowly cooling it, when we are heating a solid and then slowly cooling it, this process of heating a solid and then cooling it is known as annealing. Right? Now, sometimes what happens is during this process, when we are heating a solid and then slowly cooling it, the amorphous forms that convert into crystalline forms. As a result of which, the glasses of old buildings, when they get heated up during the day and then they start getting cooled up, so the amorphous forms they start converting into crystalline forms. Crystalline forms, as a result of which they start appearing milky. So this is one question which is important from your examination point of view. Now when we've done the classification now, we classified the solids into two, one which was crystalline and the other one was amorphous. Now we are going to further classify the crystalline solids on the basis of constituent particles and the forces of attraction between the constituent particles. Basically, you have done in class 11 that why do matter exist as solid, liquid or gas. Okay, there are two, you can say, concepts which are present in any state of matter. One which is known as the forces of attraction and the other which is known as the thermal energy. Okay, so we know that all electrons are moving all the time or all molecules are also moving all the time. When we are talking of solids, in case of solids, the forces of attraction are much more than the thermal energy. There's always a competition between the two, that is the forces of attraction and the thermal energy. अब अगर उसमें कंपटीशन में जो फोर्सेस ऑफ अट्रैक्शन है वो ज्यादा होंगे तो वो जीत जाएंगे, then the matter appears as solids. When we are increasing the thermal energy or we are increasing the temperature, तो वो टेम्परेचर क्या कर रहा है, अब थर्मल एनर्जी को इंक्रीज कर रहा है, क्योंकि थर्मल एनर्जी इंक्रीज हो जाती है with respect to the forces of attraction, the solids get converted into liquids. And then further on increase in temperature, the thermal energy becomes very large as compared to forces of attraction, as a result of which the liquids they get converted into gases. So ये एक competition हमेशा रहता है thermal energy और forces of attraction में. तो as we just said कि जो solids हैं, solids में forces of attraction सबसे ज़्यादा हैं. तो वो forces of attraction कौन-कौन से type के हैं जो कि constituent particles को जोड़ के रखते हैं या bind करके रखते हैं, वो हम इस सेक्शन में पढ़ेंगे. Okay, so let's classify the crystalline solids. Crystalline solids are classified on the basis of constituent particles and the forces of attraction between constituent particles. The first one which we are going to classify is molecular solids. Molecular solids. जो molecular solids हैं, उसमें constituent particles are molecules. The constituent particles in molecular solids are molecules. There are three types of forces of attraction. The first one, they are London forces or dispersion forces. These type of forces of attraction, they are present in non-polar solvents. Non-polar solids, sorry. They are present in non-polar solids. London forces or dispersion forces, they are present in non-polar solids. Non-polar solids means that both the atoms, they are identical. For example, iodine. You have studied about these forces of attraction in class 11. कि dispersion forces क्या होते हैं, non-polar solids क्या होते हैं. Non-polar solids में there is no dipole moment, as a result of which the dispersion forces they come into existence. ठीक है. Second जो हमारा है that is dipole-dipole interaction. Dipole-dipole interaction. Dipole-dipole interaction जो है वो प्रेजेंट होगा polar solids. It is present in polar solids which have a net dipole moment. For example, solid HCl, solid hydrogen chloride. The third type is हाइड्रोजन बॉन्ड. ओके, सो जो हाइड्रोजन बॉन्ड है वो आपको मालूम है कि हाइड्रोजन बॉन्ड इज द बॉन्ड बिटवीन हाइड्रोजन एंड अ हाईली इलेक्ट्रोनेगेटिव एलिमेंट. फॉर एग्जांपल, वी कैन टेक ओवर हियर HF, राइट? So आप यहाँ देख रहे हो कि there is a bond between fluorine and hydrogen. This dotted line जो कि यहाँ पे show की गई है, and over here also this is the hydrogen bond. So molecular solids, they are of three types. In first, non-polar molecules are present. The forces of attraction are London forces or dispersion forces. In the second type, polar solids are present, in which dipole-dipole interactions take place. An example which we have taken is HCl. And in the third, hydrogen bond is the force of attraction, for example in solid HF. So this is the first kind of solids under crystalline solids. They all are crystalline solids which are coming under molecular solids. So let's go on to the second one. The second type of solids we have is ionic solids. Ionic solids. As the word is suggesting, in ionic solids, the constituent particles are ions. The constituent particles are ions. And the forces of attraction over here are electrostatic forces of attraction. Electrostatic forces of attraction, because ions would be having a positive charge and a negative charge. Therefore, we say that they have electrostatic forces of attraction. All ionic compounds, they come under this category. For example, NaCl, sodium chloride, magnesium chloride, so these are a few examples of ionic solids. When we are looking at the characteristics of ionic solids, the ionic solids, they are hard and brittle. Okay? Then second, they have very high melting points. They have high melting points. Why high melting points? क्योंकि forces of attraction जो है वो electrostatic forces of attraction है, strongest forces of attraction है, तो उनको break करने के लिए हमें ज़्यादा temperature चाहिए bonds को break down करने के लिए, इसलिए उसकी जो melting points हैं वो high होते हैं. Then they are poor conductors of electricity in the solid state. They are poor conductors of electricity in the solid state, but they become good conductors of electricity in the molten state and the liquid state. Why are they poor conductors in the solid state? Because in the solid state the ions are not free to move about, therefore they become bad conductors of electricity in the solid state. Okay? फिर उसके बाद next they have high enthalpies of vaporization. They have high enthalpies of vaporization. They do not easily convert to the vapor state. A lot amount of energy is required for this conversion. So this is the second type of solids, which is known as ionic solids. Then the third type of solids is covalent solids. In covalent solids, the constituent particles are going to be atoms. Constituent particles are atoms, and the forces of attraction are covalent bonds. These are covalent solids, right? In which the constituent particles are atoms and the forces of attraction are covalent bonds. Now, covalent solids, an example which we can take is allotropes of carbon. Graphite and diamond. In case of graphite and diamond both, the atoms of carbon are present. In graphite, each carbon is covalently bonded to 3 other carbon atoms, whereas in diamond, each carbon atom is covalently bonded to 4 other carbon atoms. Graphite has sp2 hybridization and diamond has sp3 hybridization. As a result of which, because of one free electron, graphite is the only non-metal which is a good conductor of electricity. Diamond is a bad conductor of electricity because no free electron is present. In case of graphite, the hybridization present is sp2, and in case of diamond, the hybridization present is sp3, as a result of which diamond is the hardest substance known and graphite is softer. It is used as a lubricating material for machines. So this is the difference between graphite and diamond. Then the fourth type of solids we have metallic solids. In metallic solids, the constituent particles are going to be metals. Metals, as you know, have electrons and they have positively charged kernels, as a result of which the forces of attraction in metallic salts are known as metallic bonds. And these solids, example which you can write is all metals are metallic solids. Copper, mercury, silver, gold, aluminium, iron, all come under the metallic solids. Characteristics of all the solids will be provided to you in the form of notes through the links. So, this is all about the introduction of the chapter solids. In the next section, now we are going to go on to crystalline solids, their structure and their properties.